In this video, we're going to show the installation of a heat pump unit and the copper line set. Essentially, this is a video to help instruct the installers at Kalo Services on best practices for installing heat pump condensing units specifically. This video will show typical install conditions that we see in Florida. There's always going to be a variety of installation configurations in any location in the country, but keep in mind that this guide is very specific to Florida, and even more so specific to our market in Central Florida. We're going to do additional videos on gas furnaces showing typical floor mount side return type of applications. But don't get too fixated on the specifics of the layout. Instead, focus on the best practices of the install itself, which applies to many different types of systems. Before you leave the warehouse, you need to make sure you have the correct unit. Check the model number against the proposal to ensure that you have the correct equipment and all the correct accessories. Whenever you're going to be loading a truck, make sure to do it safely. Use a forklift or a team lift. Here we show the air handler. We're going to show portions of the air handler installation, but we aren't focusing on that in its entirety. Next, we show the prefabricated concrete pad. You'd bring that if one is required. Here we show our hurricane straps, heat strips, thermostat, float switch, circuit breaker of the proper size, copper tubing insulation, sheets of duct board, mastic or duct sealant, white fab, which is a white sticky mesh tape, UL-rated silver tape, plywood, corrugated tubing for covering the line set outside, and the copper line set itself if we're replacing the line set. The corrugated tubing, plywood, and ductboard are very Florida things that we use in our market. The corrugated tubing is for code compliance and protecting the lines when they come out of the ground. We use plywood for our platform tops. Here we're just showing all these necessary items that we want our installers to bring with them. Once you get to the site, the first thing you want to do is identify the application. Check to see if you'll be replacing the concrete pad or not. Safely unload the condenser, then confirm that it's a match for the replacement unit. The 36 in the model number means these are both 3-ton units, because it's 12,000 BTUs per ton. Check that the tonnage is correct by looking at the manual S and manual J calculations for the job. Next, unbox the unit. Where possible, use the box as your garbage bin to keep your workspace neat. Check your disconnect. The proposal will dictate whether or not it's to be replaced, but inspect it to make sure that it is in good and serviceable condition. In our market, we're licensed electricians, so we can replace those if they need to be replaced. Other markets may be different. Always safely remove the disconnect and test to make sure you do not have 240 volts from leg to leg, and then also check for 120 volts from leg to ground as shown. Next, confirm your wire sizing. This can be done by referring to a wire sizing table, which is based on NEC Table 310-16. Make sure you have the appropriate wire sizing or larger going into the disconnect and out as required by the data plate. That will be listed as your minimum circuit ampacity. It's also going to list your maximum circuit breaker size on the data plate. Ensure that you have the appropriate circuit breaker that matches the data plate. Next, you're going to prepare the system for recovery. Here I'm showing the use of core remover tools to remove our cores. We remove cores to speed up the recovery so we don't have that restriction to refrigerant flow. You'd remove those Schrader cores from both service valves, the suction and the liquid. Suction being the low side and liquid being the high side. Here I'm showing the use of an analog manifold set. You could also use a set of probes and hoses to do this, or use a digital manifold. For recovery, I prefer using a simple analog manifold because it's always possible that the existing system has contaminated refrigerant or oil, so I'm less worried about contaminating my inexpensive analog gauge. If you're starting with a fresh recovery tank, you want to make sure to pull a vacuum on the tank before you recover refrigerant into the tank. That way there's no air or moisture in the tank. Take note of the WC, or water capacity, of the tank. That's the amount of water a tank can hold. Also the TW, or tear weight, the empty weight of the tank. In order not to overfill a tank, we suggest using the recovery tank calculator on the HVAC School app or similar. For example, if this tank is empty, it will only weigh about 16.6 pounds because that's the tare weight or empty weight. You would then zero the scale and begin your recovery. If it had refrigerant in it beforehand, then you would need to take account of how much refrigerant was in it, and the whole point of this is to ensure that we don't overfill the tank beyond 80% full of liquid. You want to pull a vacuum below 500 microns on the tank. Here we show a vacuum pulled to 300 microns. Next, you close off the tank and disconnect your vacuum pump. You're going to save the vacuum pump for pulling the vacuum on the system later. Now bring your recovery machine and refrigerant scale. You can see that I put the tank on the scale and zeroed out the scale to begin receiving refrigerant into the tank. Now's a good time to note the designed factory charge for the unit you're removing. That way you can know what to anticipate you're going to get out of the system in terms of refrigerant weight. Again, you may get more or less depending on if the system had a leak, if somebody overcharged it, or if it has a long line set. Once you get all your hoses connected, remember to attach a liquid line filter dryer in line to protect the recovery machine. Open your core tools on the system and open your hand valves on the manifold. Purge the hose going into the recovery machine to make sure you're not bringing in air. Then you purge going into the tank. Now you can recover. Here we show inverting the tank first. Recovering into the vapor side of the tank with the tank inverted has been shown to be the fastest way to recover because you don't have a dip tube on the vapor side of the tank. And inverting it just ensures that you're filling from the bottom up, which helps dissipate heat a bit more easily. It's not a huge difference, though, if you invert the tank or keep it right side up, so do whatever seems best to you. You can start your recovery machine now. Wait until you recover to 0 psi or slightly below 0 psi. Make sure you don't overfill your tank by monitoring the weight of the refrigerant going into the tank. Next, you purge your machine and shut off the tank. Not all machines have a purge option, but this NAVAC NRDD machine does. At this point, you would want to note how much refrigerant you remove from the system to stay in compliance with EPA regulations. Also, tag the tank with the job, equipment, and amount of refrigerant put into the tank. This way, you can keep track of how much refrigerant is in your tank. You can now disconnect everything because the system is now empty of refrigerant. Now begin disconnecting all of your electrical connections. At this point, you would have already tested to make sure that everything is electrically turned off by testing from leg to leg and leg to ground as shown before. Before you disconnect your low voltage on the outside, you would also want to make sure your disconnect is turned off to the inside unit, your furnace or your air handler. That way you won't create a short circuit on your low voltage controls. At this point, you need to know whether you'll be replacing the copper or reusing it. In the case of reusing it, you'd use a process called pipe wiping to remove any residual oil from the existing copper lines. If you need to replace the copper in an underground application, you need to dig down to the chase and expose it to begin preparing for running new copper. Here we show how a typical chase application would look. The one shown here would be a very short chase application. Regardless of your process, you need to cut your copper at the inside and outside. Here we show cleaning the copper before you cut it with a proper tubing cutter. This is one of the best practices because it ensures that you don't have to clean it when it's already been cut, which can result in pieces of copper and contaminants falling into the lines. When working with copper, one of your most important tasks is to ensure that no solid contaminants make it into the lines. When using a tubing cutter, cut the copper slowly with many rotations to ensure that you don't bend or oval the copper. Do the same on the inside and outside of the copper line set. Now you're going to cut the drain using a PVC cutter. In this video, we're showing an indoor trap. This is not typical in Florida, but I'm showing this trap and vent application because it is an industry standard and would also work just fine if it were done this way. Typically in Florida, we have a clean out and then it runs outside. That's because we don't often have room to put a full indoor trap in place. Keep in mind that in this situation, there is also a trap underground. So adding an additional trap isn't very valuable. Now we're going to show the pipe wiping procedure if we were going to reuse the existing copper. Here we insert a foam pig into the pipe wiper. We put our catch at the bottom over an oil pan with a rag. This will catch any residual oil that would blow out of the system. We use a nitrogen tank and a hose, typically set to about 100 psi. We open the valve, and this forces the pig through the lines and cleans out any oil or contaminants in the lines. You'd also repeat the same process on the liquid line, which we don't show here. Next, if you're going to reuse the drain line, you always need to clean it very well. The best way to clean the drain in this application is by hooking up a shop vac to the outside and running water through it to clean it out. We don't show this here, but you'd also need to put a cap on the vent if this were the application to allow us to draw the water through rather than just pulling air through the vent. There are some alternative methods we can use, such as nitrogen or CO2. But even if you use those methods, be sure to finish up using this procedure of flowing water through with a shop vac. Always refill the trap when you're done and make sure the water pours out freely. Sometimes this may be hard to observe, and so you could simply put a dry rag or a cup underneath the drain in order to ensure that water did come out when you look again outside. Now you can pull out the old copper and drain line if you're replacing both and prepare to run new copper. This is if you're not doing the pipe wiper procedure. This is in cases when you're replacing the copper line set and not reusing it. Next, we're going to show what to do if you're going to replace the concrete pad. We would often do this if the existing pad was prefabricated and damaged, if the existing pad was insufficient in some way, maybe well below grade, or if the existing pad was made of plastic. Here we show a good procedure, if not maybe a little bit overkill, for leveling the pad. First using a level, then moving some dirt around to improve the leveling of it. A rake and a tamp can be used to create a nice firm foundation. Then use the level to determine that we're level in all directions. Next, install the pad and check the level once again. In general, it's a good best practice to have about 2 feet of clearance from the condenser to the wall and about 1 foot in all other directions. But that can vary based on manufacturer specs and application. You'll also want at least 2 feet of clearance between your dryer vent and your disconnect and the edge of the condenser. That gives you proper service access to your disconnect and ensures that you're not going to pull in a bunch of lint from your dryer vent. Now we're going to show preparing the copper to push it. One of the best practices we found is looping your liquid line around and pinching it down into your suction line. We find this to be one of the best practices even if you're running attic copper because of the possibility of caps coming off and the copper becoming contaminated. The loop in the liquid line makes it a little easier to pull through. But again, you can push the bare ends, just make sure you braze them shut before you do so. The plastic or rubber caps can easily come off, which can result in the line set being contaminated. When you use a torch for brazing, we recommend using an IR3 tint set of safety glasses, like the Titus glasses shown here, as recommended by OSHA. Wear appropriate gloves and have a fire extinguisher handy. Here we're going to show you a basic procedure for setting up torches in the first place. Make sure everything is nice and snug. Keep in mind that the acetylene threads are reverse threads, meaning they're left-handed threads rather than right-hand threads. We're going through and making sure everything is nice and snug but not over tight all the way around. We don't want to have a gas leak. Also keep in mind, do not use any sort of oil unless it's specifically designed for it on your oxygen regulators. We're turning out or counterclockwise our regulators and then we're opening our tanks. We're doing that first to make sure we don't have leaks where the regulators attach to the tanks themselves. Again, some of you will believe this is overkill, but for somebody newer in the business, we want to get them in the habit of setting up their torches appropriately. Next, turn in or clockwise your regulators so that you have a bit of outlet pressure, then test for bubbles on the outlet side. As a general rule, when you're setting up the outlet pressure on your torch regulators, you need to do this with the torch handles open, meaning with the gas flowing. You want to set your manifold somewhere around 5 and 5 or 10 and 10 for your outlet pressure. Some people will set them to 7 and 7. I was taught to set them to 7 and 11. In general, it's going to be in that range of 5 to 5 and 10 to 10. Some of the torch manufacturer literature will tell you that it should be balanced, but as I mentioned, I've done it at 7 acetylene and 11 oxygen for most of my career, and it works just fine. Now we're ready to light our torch. Most books will tell you to open the acetylene first, light it, then bring in the oxygen. That's a perfectly fine way of doing it. It does create some carbon that can tend to float around, but if you're outside, that's totally fine. Once you get more used to brazing, and specifically with your own torches, you'll be able to open up both the oxygen and the acetylene at the same time and light it. This is something that comes from experience. So here we show lighting the torch straight away, but generally you would just open your acetylene first, light it, then bring in the oxygen quickly. The ideal flame is a neutral flame or slightly carburizing, also known as a reducing flame. That means that you have a slight secondary feather. Really, you're going for as neutral of a flame as possible. You don't generally want to use an oxidizing flame because it produces oxides that can cause issues with creating a good bond. An oxidizing flame is excess oxygen, and a carburizing flame is excess acetylene. We recommend using a 15% sil-phos rod, silver and phosphorus alloy. Here we're showing that you heat the base material to dark cherry red and then apply brazing material. We do show this quickly. Some people will note that we did not flow nitrogen for this, and that's just because this section of the tubing is going to get cut off before we do anything with it. So nitrogen is a non-issue at this part of the process. Now we're going to shut off our tanks and our regulators, allow our copper to cool, and tape up the ends so they don't get damaged as we pull them through. We're also going to attach our thermostat wire to our drain. In some cases, some people run them together all the time. Some people run them separately. Do whatever works for the application. Here we show pushing it all the way through and pulling it up. In many cases, you won't be able to do that with the drain. You'll get in the part where it hits the 45 and put a 45 on it to bring it up. If you are going to cut the drain below the platform, be sure to glue it properly. And make sure that it doesn't leak. Once you get more than enough excess copper, drain line, and thermostat wire above the platform, you can seal the chase. Sealing the chase is mostly just to keep insects out. It really isn't going to be completely watertight, but foam we find is generally the best policy. Next, we show placing the plywood platform top in place. This is more of an air handler installation procedure, so we're not going to focus too much on that. Here we're using a tubing bender to bend the copper in place. We show how to change the different sizes to bend both the 3/4 inch and the 3/8 copper. Whenever you're going to pull insulation over the tubing, put the cap back on first. That way you won't get shards of the tubing insulation into the copper. We use inexpensive metal clamps to hold back the tubing insulation so that we can work without damaging it. In some cases, if the tubing insulation is close, you may need to put a wet rag around the tubing insulation to prevent yourself from damaging it while you braze. Here we're showing using fittings to make the final connections. In some cases, you can do this just by bending the tubing with a bender. We always install our liquid line filter dryer on the inside nearest to the air handler for optimal protection of the metering device and to keep the filter dryer out of the elements, which prevents rusting. Now we're going to bring in our entire drain assembly at once. As we discussed before, this indoor trap is something we really don't do in Florida, but we showed it this way because it would be a traditional setup in other markets. This is our cleanout, and this is our vent. When gluing copper, apply glue to the male side of the connection and hold it in place. Whenever possible, give it a quarter turn once you insert it into place. Here, we're not showing using a primer. If it were a pressurized system, we would definitely use a primer. We find that as long as the PVC is clean, a regular medium cement works okay. I know this may be somewhat controversial, so if your company or your local authority having jurisdiction requires primer, then use primer prior to gluing. Because we install carrier units, we're showing using an outdoor heat mode piston. Not all of them have this anymore, but this is a traditional part of a carrier heat pump install. That piston needs to be in place, and we need to make sure the Teflon seal is also in place, because that's what actually seals it. We also use a little bit of nylon glue on the threads just to make sure it all goes together nice and smoothly. Tighten it down with a wrench at the end to make sure it's tight. But again, it's the Teflon seal that does the sealing in this type of chat-lift connection. This is not a flare. Next, we're going to use the tubing bender in both the inward bend and the outward bend. We're showing how to use the adapters in order to bend the tubing in the opposite direction. We do the same with the liquid line. Now we cut the tubing to fit, making sure you leave plenty of excess. At this point, you're going to pull the Schrader cores out of the new system. Now we're showing this using the full core remover tool, but you could use the one on the back of your screwdriver, whatever you want to use. But at this point, there's no refrigerant in the lines. It's all stored in the condenser, so it's safe to pull those cores out. Now we're going to prepare the system to flow nitrogen while we braze. As you can see, we attached the suction line, which means it's going to flow in the opposite direction through the evaporator coil and back to the liquid line. You're going to want to protect everywhere you work as you braze. You can use a rag that's soaked in water or wet rag by Refrigeration Technologies, which is a heat-blocking putty that does a similar job, and it's a bit easier to get into tight spots. So keep in mind that wherever we show wet rag by Refrigeration Technologies, you could also use a normal wet rag. Now we're going to prepare our torches, similar to how we did earlier. In this video, we're going to light them by opening both at the same time, as I already mentioned. But in general, best practice is to open the acetylene first and then bring in the oxygen. We're going to do another video at some point showing the setup of brazing torches in more depth. This is a rather simplistic view of it, but we do want you to get the neutral flame as seen here, not the tiny oxidizing flame, and not the big secondary feather of the carburizing flame. Here we show the Western Enterprises nitrogen flow regulator that allows us to flow a very small amount of nitrogen through the tubing. If you don't have a special flow regulator like this, you can use a separate regulator on top of your regular nitrogen regulator that will flow at 3 to 5 SCFH of nitrogen during brazing. Now we're going to heat the connection by starting on the male end, getting it nice and hot to that dark cherry red, and conducting that heat into the joint connection. The color we're showing here is about the color you want it to get. It's hard to represent this on a computer screen and there will be some variation, but that color is called deep cherry red or dark cherry red. That means our base copper is around 1200 degrees, which is also the melting temperature of most brazing alloy rods. Our goal is to get that entire joint hot enough to draw our solder in via capillary action as shown. Getting a good cap on the end is nice, but it's much more important that you get the joint to the right temperature so that you can pull the alloy into the joint. Next, we're showing moving to the inside to braze, but generally speaking, you'd do the inside first. Then you'd go outside and do the suction and liquid line at the same time. Here we're just going to continue showing the process, kind of following the flow of nitrogen through the system. When working indoors, make sure you're protecting all the surfaces and areas and that you still have your fire extinguisher handy. If you have a TXV indoors, protect the TXV and the TXV bulb. You could also just remove the bulb from the suction line to protect it if that's easier. Always be careful when handling a TXV or a TXV bulb. Now you do the same thing as before. You're going through the system, getting each joint to that dark cherry red to cherry red color, making sure you're drawing the alloy into the connection. Generally speaking, if you braze a connection, you can let it sit about 20 seconds, and then you can go ahead and cool it off with a damp towel or rag. Here we're showing brazing all of them before cooling them, but that's not generally how you do that. If you find that Refrigeration Technologies wet rag has become hard or difficult to deal with, you can put a few drops of water in it once you return it to the container. Now you go through the system with your damp towel, cool off everything, and clean off each connection. Again, you don't want to do that instantaneously after you finish the braze, but about 20 seconds or so afterwards gives it enough time to set up and cool down so that you can cool it without stressing the connection. Now you're going to inspect each connection with a mirror to make sure they all look as they're supposed to before we move on to our pressure test. Now we're preparing our system for our standing pressure test. You're going to pressurize the system to a fixed number. In this case, we're pressurizing it to 250 psi. A good rule of thumb is to look at the lowest pressure rating on both the evaporator coil and on the condenser and use that as your pressurization pressure. Once we get it under pressure, we're going to test each connection with a leak reactant. Some people call them soap bubbles, but this is a specially designed leak reactant to show even the tiniest leaks. When you are pressurizing the system, make sure you set it up to an exact number so that you can see even tiny changes in your pressure. Your best bet is to use a digital manifold or digital probes and to monitor the changes very carefully. Keep in mind, if you have a hard shut-off TXV, the pressures will become unbalanced on the high side and low side once you hit around that 250 psi number in some conditions. Keep in mind that if you have a hard shutoff TXV, an HSO, or often called a non-bleed expansion valve, the pressures will become imbalanced on the high and low side once you hit a particular point. So in some cases, in order to hold a fixed pressure on both sides, you need to actually allow it to equalize through the gauges. You're now going to leak test each connection with the spray-on leak reactant, checking for bubbles visually. Don't skip this step. Look for even tiny microfoam in the bubble solution. Here we show what a good size leak would look like with Refrigeration Technology's Big Blue leak reactant. Next, clean the solution off of all the connections. The next step is showing electrical connections. You could actually have begun some of these connections while you were waiting on the pressure test. Now you can begin to make your electrical connections. Again, this doesn't need to be done before your vacuum. In most cases, you're going to begin pulling your vacuum at this point. We're just showing this part here. First, you connect your high voltage. Now you connect your low voltage. Snip into the end of the wire and peel back the jacket using the string or one of the unused conductor colors. Then you cut the jacket off and snip off the wiring portion you cut into initially. This ensures that you don't have any nicks in your wires. When stripping back the insulation from each conductor, only do it as long as you need to make a good connection. You don't want to leave any bare wire left over. Next, you connect each conductor one at a time. Yellow for your contactor, red for constant 24 volts, black because that's the color carrier uses for common, white for your electric heat, and orange for your reversing valve. Keep the wire nuts pointed upward to keep moisture out of the wire nut, and put a zip tie around them as shown to hold them in place. Wire routing varies from system to system, but always keep your wires neatly routed, leaving appropriate levels of excess wiring, and not leaving any of your connections in tension, meaning where they want to pull apart. With all of your conductors, always run them through appropriate grommets and strap them so that they won't chafe, creating a short circuit. Now we anchor down our condenser. We usually use the factory condenser base pan screws, and we make separate holes in the concrete pad using Tapcons. If you're going to put screws into the equipment, make sure you're never going to drill into the condenser coil. The number of straps and the location will be dictated by engineering and/or the local municipality. We also recommend sealing the outside chase. In both cases, the sealing is really mostly for insects, just to make sure we're not going to get them into the space. It's not going to do a whole lot for water. When installing the drain in general, ensure that it's about 2 feet from the house if possible. You can bring it a little closer in some cases, but try to keep it away from the slab as much as you can. Once you've passed your pressure test, now you're okay to discharge your nitrogen and begin pulling your vacuum. A good nitrogen pressure test on a typical residential system will generally take about half an hour to prove no leaks if you're using a high-resolution pressure gauge. If you're using something like an analog gauge, it can be much more difficult, and it's much more likely that you will leave a leak just because you don't see that small change in the needle. First off, vacuum is often called evacuation or pulling a vacuum. Before you pull your vacuum, you want to ensure your vacuum pump is working exactly as it should. So step 1 is to check the vacuum pump oil to make sure that it's clear and clean and that it's at the proper level. If it's been a while since your last oil change, now would be a good time to change the oil in the vacuum pump. Next, take your vacuum gauge, often called a micron gauge, and hook it directly to the pump. You need to make sure the vacuum pump itself will pull below 100 microns in less than 30 seconds. This is typical. A good pump will even pull down to 30 microns or less than that. Now, connect your micron gauge to the liquid line valve. In this case, both of our Schraders are still out of the suction and liquid line. Here we're showing the True Blue vacuum hose, which is one of the highest capacity vacuum hoses available on the market today and the ones that we use primarily at Kalos. Now turn on your vacuum pump and let the system pull down. Generally within about 5 minutes, you're going to be at or below 500 microns, and we try to get it below 300 microns. You're going to notice that this is significantly faster than when you're pulling on the entire system, like your condenser coil or your compressor after repair. This is because the only thing you're pulling a vacuum on right now are your copper lines and your evaporator coil. And since generally they're brand new, or they've been recently cleaned, it's not going to take a lot to get to a deep vacuum. Now do your isolation test by shutting off the suction valve and ensure that the vacuum doesn't decay significantly. Decay in this case just means that the micron level rises rapidly. Generally speaking, you don't want it to go above 500 microns in 10 minutes of decay time if you pull down below 300. On a typical residential system, staying below 500 microns in 10 minutes would adequately confirm that there aren't significant leaks and that you have a deep vacuum. Now you're ready to release the refrigerant into the lines and into the evaporator coil. First, open the suction service valve, and then the liquid valve as suggested by manufacturers. Now put your Schrader cores back in. It's important that you get this sequence correct. You do not put Schraders back into the system until after you have released the charge. Otherwise, you're going to ruin your vacuum. Now the charge is released and you can put your Schrader cores back in the system. Follow this process exactly. This could actually be done later, but we showed at this point that we're going to add the corrugated tubing that protects the copper from lawn equipment. That's the only reason it's there. It doesn't create any sort of a watertight seal. Make sure your thermostat is installed and wired properly. Ensure that it's level and that you don't leave any fingerprints on the thermostat or on the wall. Now we're prepared to run our condenser by setting down the temperature. Before we do, though, we want to take note of the line length, as well as the proper charging methodology for this system defined by the manufacturer. It's best to take both of these things into account. Generally speaking, you won't be adding any refrigerant charge unless your line length is over 15 feet. However, that's not always the case, especially in cases where the system has a microchannel condenser coil, so you need to follow your manufacturer's literature. We also have a charging calculator for different line lengths on the HVAC School mobile app, because you use line lengths to figure out how much additional charge to weigh into the system. In addition to that, you still monitor your pressure, subcooling, superheat, and follow your manufacturer's literature for charging. Get out the scale and place your refrigerant charging tank onto the scale. Here, we're showing how to use a core depressor to control the flow of refrigerant. You'll also want to use a charging orifice on the tank because you'll need to charge in the liquid state. This ensures that you won't get liquid into the system as you're charging while it's running. It's worth noting that if you measured your line sets beforehand and you know you need to weigh in a certain amount of charge, you could do that before you even release the charge from the system into the line set. You can charge it into the line set when the system is still under vacuum. This will save just a little bit of time. Otherwise, you have to wait until you run the system in order to add refrigerant, and you always add refrigerant into the suction line while it's running. Again, only add refrigerant if you know you need to based on your line length and your readings. Make sure your Schrader core is on the side port if you're using a charging tee. Here we're showing a charging tee and field piece probes and hoses because we find this to be a great method for testing and charging the equipment. Use your line temperature clamps to measure your liquid line and suction line temperatures. Now, place in your disconnect, and the system should begin running if all the time delays have expired. As soon as the system starts running, you want to listen for any abnormal sounds and be ready to pull the disconnect immediately if anything goes wrong. Now, while the system is running, you'll want to see if we have proper output voltage from the contactor. Check the amperage on your fan motor and the amperage on your compressor. Those should be below the rated amperages listed on the data plate. Now, monitor your system pressures and specifically watch your subcooling. You'll only want to make adjustments till after at least 20 minutes of runtime, but hopefully even more than that. Here we're showing that we're measuring a low subcooling using the MeasureQuick app. We're showing a 7.3 subcooling with a listed subcooling on the data plate of 10. Now that's not really realistic here because we know we only have a 15-foot line set, but we're showing adding charge for the sake of the video. If you want to know more about how to add charge to a system, we have a completely separate charging by subcooling video that you can watch. Again, we only do this once we've taken all of our measurements and the system is run a sufficient amount of time, but we're going to show adding some refrigerant until we get to the target 10 degrees of subcooling. Here I show only having put in 4.75 ounces, and you can see we achieved 10 degrees of subcooling. Now again, only do this after appropriate amount of runtime. Now we're going to quickly show how we would use digital psychrometers, one on the return and one on the supply duct, in order to monitor the delta T, which is the difference between the return and supply temperature. We're using MeasureQuick, and you can see that we're in the green zone at 20 degrees for this particular situation, which is what we're looking for. Now we're going to use manometers in both the return and the supply in order to measure our total external static pressure. Generally speaking, for these types of systems, a total external static of 0.5 or lower is what we're looking for, but you need to look at the design literature to see what's appropriate in your application. Once you've done all your tests and you've ensured that the system is performing properly, you can go ahead and reverse the process. Remove all your ports and probes and reassemble the system completely, making sure you clean up everything. Before putting caps back on, make sure the rubber seal is still in the caps. Finally, test the drain. Make sure it drains properly by filling the trap, and when it's running, make sure the condensate drain is draining if you're running in cooling mode. Again, we focus primarily on a heat pump condenser install with a Central Florida style application. We didn't focus a lot on the things you need to do for the air handler or the furnace. We'll do those in some future videos. Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.